All right, so applications of derivative, okay? So if you have the derivative with respect to x of some amount, then that's the rate at which the amount is changing. So if we're draining a swimming pool and R of t represents the amount of water measured in cubic feet, that is in the swimming pool at any given time, measured in hours, then R prime would be the rate at which the water is changing. What would the units of R prime of t be? Yeah. Cubic feet per hour. Excuse me, I've got to go get a tissue. Oh no, I've got one tissue left in my secret stash of tissue. Okay. So the integral from a to b of the rate would be the amount of change that happened from a to b. Okay, so in the context of this example, explain what this represents. Because we're talking about water changing. So R of B minus R of A would represent what?
The amount of water that drained from the swimming pool.
Okay. Yeah, sort of. It would be
The difference in the water from that time.
right. Yeah, it's the change in the level of the water. That would equal all of this. I just wrote that in a different order, but it's the same. It represents the amount of change from t equals A to t equals B. I hope that wasn't really loud for people watching. Sorry. Okay, so we have this table that's the velocity of a particle at given values of t, and t's in minutes. So we have t minutes here, and we have v of t in feet per minute here. Are y'all cold? Do you think it's cold in here? No, you're not? I'm just freezing to death? Okay. It's just me. Shivering. What'd you say?
I'm kind of cold, but I think we're the only two without a jacket.
That's true. Did I even bring a jacket? Yeah, I brought a jacket. All right. Approximate the value of the integral from 0 to 30 of vt dt using a midpoint. Oh my gosh. Use correct units of measure and explain what this value represents. All right. So we're going from 0 to 30 with a midpoint. So that would be like here to here, and that's your midpoint. Here to here, and that would be your midpoint, and then here to here, and that would be your midpoint. So each one is 10. dt is about 10 times 1.6 plus 10 times, what's the 3.1 plus 10 times 1.6 again. Do that math. What'd you get? 63 what? Feet. Okay, this is 63 feet. So what does this 63 feet represent?
The change in velocity.
No, go up one. We took an integral. Change in position. Yeah. So this, from 0 to 30 of VT dt represents the amount of change in position. Of our little particle. From t equals what? 0 to 30? Alright, minutes. Can't even read that. That's better. Alright, what is the value of the integral of the acceleration of t dt from 5 to 25? And using correct units, explain what this value represents. Alright, so the integral from 5 to 25 of a of t dt would equal what goes up 1? Right? v of 25 minus v of 5. Which is v of 25 is 1.6 and v of 5 is 1.6. So that's some easy math. 0 what? Or feet per minute. It's okay. So what does that represent? What does the integral from 5 to 25 of a of t dt represent? Okay, it represents the change in velocity of the particle from 5 to 25, but there wasn't a change, right? Okay, it represents the change in velocity of the particle from t equals 5. I'm curious, on the videos, can you hear what's happening next door? Okay, just checking. Alright. Oh, I don't have it back. I forgot. Temperature in a tub. The temperature of water in a tub at time t is modeled by a strictly increasing twice differentiable function, W, where W of t is measured in degrees Fahrenheit, and t is measured in minutes. Okay, so we've got time and WT degrees Fahrenheit. So this is, anyway, this is, they've told us it's twice differentiable, but is this a rate right here? The 55, the 57, the 61, all that, is that a rate? No, that's the actual temperature. It's like, you know, I put my little thermometer in the tub. Okay, it's 55 degrees. It's 57 degrees. That's some cold bath water. So, anyway, this is not a rate. Okay, but using the table, estimate the value of W prime of 12. Using correct units, interpret the meaning of this value in the context of this problem. So how can we estimate the value of W prime of 12? Find the average of what? Which two? 9 and 15. Okay. So W prime 12. I was going to just have y'all do this one on your own, but since we have two people out, like, you can still do it on your own, but I guess I'll put the answer up here too. So that would be W of 15 minus W of 9 over 15 minus 9. And then W of 15 is what? 67.9 and 61.8. And that's 6. What's negative? I don't know. What is 6.1 over 6? Oh, that's not right. You ever have other stuff left over in your calculator? And you just start adding to it? Alright, so this is 1.017 degrees Fahrenheit. But is that it? What's left? What else do I need? Yes. Perfect. Okay. So now interpret the meaning of this value in the context of the problem. What does that mean? Yeah? How do I explain? What's going on here? W prime of 12 is
a change in temperature.
Yep.
The bath water.
Yeah.
It's increasing
It,
of 1.01.
and how do you know it's increasing?
Because it's positive.
Okay. So since W prime of 12 is greater than 0, the temperature is increasing at a rate of okay.
So you can't say at T equals 12. That's the rate.
Well, we don't know exactly because we had to estimate it. Yeah. All right, now use the data in the table to evaluate the integral from 0 to 20 of W prime T of dt. W prime of T dt. Using correct units, interpret the meaning of this integral in the context of the problem. All right, so on this one, I have from 0 to 20, W prime of T dt. What's that going to equal? Yeah, it is, but how'd you find it?
W 20 minus W 0.
Which is 71 minus 55, which is 16. So what is that 16 degrees Fahrenheit? What does that represent? All right, let's see. For 20 to 25, okay, for t is between 20 and 25. The function w that models the water temperature has a first derivative given by the function w prime of t equals 0.4 square root of t cosine of 0.06 t. At least it's like a nice friendly function, right? Based on this model, what is the temperature of the water at time t equals 25? All right, let's use what we know. It's for 20 to 25. So we're going from 20 to 25. I can't write 25, but that's what we're doing. From 20 to 25, 0.4 square root t cosine 0.06 t. And that equals w of 25 minus w of 20. Now, we know this, right, from our chart. This is what we're looking for. My calculator can tell me this. So, fill in what you know. What'd you get for this?
What did you get?
2.043. And this is the one that we don't know. And what is W of 20? 71. So that means 73.043 degrees Fahrenheit is W of 25.
This is what the test is on.
Next question, pan of biscuits.
What's for lunch today?
What?
What's for lunch today?
Beefy nachos?
Also, like, you know, like,
No, I have no idea.
that sounds horrible.
Yeah. Well, I don't like how they're beefy. Like, can they just be beef nachos? Or, like, beef-like nachos? Like, they're beefy.
It's probably that rabbit that girl brought in. They tried
A girl brought in a
to
rabbit?
cook for ad.
I don't think, are they actually going to cook it?
Yeah. They're feeding it to see the different tastes. And what they feed it is going to taste.
She had it in a cage. It was,
I
yeah.
thought it was cute.
Who is this girl?
No, it's not cute. It's crazy looking. It's like one of those white ones and its eyes are red.
Ooh.
Like Christmas.
We have a bunch of rabbits that live in our backyard, and they set off our motion cameras and our motion lights all the time.
See, they never come down to my house.
They live at my house. They love my house. They love. You can come trap them if you want. See if you can relocate them. So I'm tired of my lights going off in the middle of the night. So anyway, so that has nothing to do with calculus. Video people. All right, a pan of biscuits is removed from an oven. So, by the way, if Paul Ray's still sick to his stomach and he watches this, we're going to be talking about food. Like biscuits covered in jelly and maybe some rabbits cooked on there. I don't know. You get a little gristle and some fur in your teeth. I don't know. Anyway. Where was I? Oh, so they're removed from the oven, at which point in time t equals 0 minutes. The temperature of the biscuits is 100 degrees Celsius. The rate at which the temperature of the biscuits is changing is modeled by the function b prime of t equals negative 13.84 e to the negative 0.173 t. All right, find the value of b prime of 3, and using correct units, explain this value in the context of the problem. What are you going to have to do for that?
Just plug it.
Yeah, that's just plugging it in. Just plug it in. Definitely a calculator problem. There's no way you could do this without a calculator. Christian.
I don't feel that coming.
I'm going to sharpen my pencil while y'all are working that. What'd you get? Yep. All right, so what is this value? I need a label on it. Minute, yeah. Okay, so now explain the meaning of this in the context.
It represents the rate at which the temperature of the biscuit is decreased.
And how do you know it's decreasing?
Okay, so since
Okay.
prime of 3 is
It's less than 0. Right. So you're right. It represents that it's decreasing, but we need to say that because it's negative or because it's less than 0, it represents that the biscuits are decreasing that many degrees per minute at t equals 3 minutes after being taken out of the oven.
Can you say that one more time?
You need to say, I don't know if I'm going to say exactly what I had, but you need to mention that because b prime of 3 is less than 0, it represents a decrease. That they're decreasing 8.236 degrees Celsius per minute at 3 minutes.
The rate is decreasing, or
The temperature is decreasing. And then you have to, I think you could probably do actually the next two without me, because the next one you just get your graph and explain what it means. And then the next one at time t equals 0, what's the temperature of the biscuits? And we did one almost exactly like this just a second ago. So I'm going to give you a couple minutes to try to do the next two on your own. If you have to sketch a graph and you have a calculator, that should not be a problem at all. Coffee. All right, so your graph should look something like, it can't be here. Could probably be a little bit neater than that. That's what your graph looks like, right? Okay. So what about this graph makes sense? Why does this graph make sense in this problem?
Okay, so they start an initial temperature of 100 degrees Celsius. It makes sense because it's always decreasing, because the temperature can only go down. It can't get hotter when it's taken out of the oven.
Right?
They won't reach freezing ever, which is why there's an asymptote at 0, right?
Well, remember this is the graph of B prime.
Just chemistry.
So the rate is going to always be changing, and what they're going to approach is a point where because this is the graph of the rate changing. That's why it's always negative. At the beginning, they cool down a lot quickly, but then when they get closer to being where the room temperature is, right, it gets closer to a constant.
I
Yeah.
dug a little too hard.
What?
I think I dug a little too hard.
Yeah, so it's not that they're going to get freezing. It's just that it's going to even out because they're going to be the temperature of the environment. That's Newton's law of cooling, actually. Newton's law of cooling, yeah. We did that last year with the coffee, death, and donuts.
Oh,
Yeah, remember that?
Oh yeah, so are we still bringing food tomorrow?
Yes. Yeah. Don't get it around Paul Ray because he's going to be
Food.
not round.
$1 though.
Has to be circular. Pay with quarters. No, I'm just kidding. Yeah. All right. So at time t equals 0, or time t equals 10, what's the temperature of the biscuits? Does anybody know? You're going from 0 to 10. What is this? Negative 13.84 E. Negative 0.173 T is equal dt is equal to B of 10 minus B of 0. This can go in your calculator. We don't know B of 10, but we know B of 0. What was the temperature of those biscuits when they came out of the oven? 100. Negative? Is that what you said?
yeah.
Okay, yeah. Negative 65 point what?
Maybe 120.
Yes. Which makes B of 10 equal to 0.183 degrees Celsius. You have cold biscuits in 10 minutes. I mean, not cold, but they're not going to melt butter. I'm just saying. They won't be freezing, though. Not going to be freezing. They haven't reached absolute 0 or anything. All right, last one. We should wait for Pi Day to do this one because it's a round can. But we're not. Cylindrical can of radius 10 millimeters is used to measure rainfall in Stormville. They should have seen that one coming. During the first 5 days of a 60-day period, 3 millimeters of rainfall had been collected. The height of the water in the can is modeled by the function S, where S of t is measured in millimeters and t is measured in days, from 5 to 60. The rate at which the height of the water is rising is given by the function S prime of t equals 2 sine of 0.03 t plus 1.5. Find the value of the integral from 10 to 15 of S prime of t dt. Use correct units and explain the meaning of the value in the context of this problem. That's a calculator question. Put that in your calculator. In your calculator, you're going to have from 10 to 15 of, what is this long problem here? 2 sine 0.03 t. That's not too bad. That's 1.5. What'd you get? And what is this? What is this?
Unit?
Yeah.
Um,
Millimeters. Okay. So then what does this number represent in this problem?
the change in
Right. The amount of change in the water level from day 10 to day 15. That's the amount of change in the water level from day 10 to day 15. At the end of the 60-day, well, you're still writing, I'll wait. I know. At the end of the 60-day period, what is the volume of water that had accumulated in the can? Show your work. Okay, so if I'm looking for the end of 60 days, what do I need to go to here? What are my endpoints?
0 to 60.
Let's do 5 to 60
the
because I know that
You have that guaranteed amount of days.
exactly. So let's go 5 to 60. I'm still going to just put this in my calculator. But then when I get this answer, what am I going to do with it? When I get from 5 to 60 out of my calculator, what am I going to do with that answer?
set it equal to
No.
no.
I'm going to add the 3 millimeters that had already been collected during the first 5 days. That's what I'm going to do.
That's all it is.
Nope. Is it all we have to do? Because here's a nice trick question. What did this question ask for you to do? The volume of water. And what is this?
Change.
No.
Let's see.
It's a change, but it's the change in the water level from day 0, because I added in the first 5 days, to day 60. So we're talking about the change in water level. So what did I just find? I have a cylindrical can of water, and the water level changed. It was here, and then it went here, and then it went here. So now it's here at 166.565. It's my height, right. So if I'm going to find the volume, remember volume is pi r squared h. So that's pi, what's the radius on this thing?
10.
Times h. I'm going to leave this in terms of pi. 1, 2, it's going to be 1, 6. That's my volume of water in the can at the end of day 60. Alright, last one. The rate at which people enter an auditorium for a concert is modeled by the function r given by r of t equals 1,380 t squared minus 675 t cubed for 0 to 2 hours. R of t is measured in people per hour. VIP tickets were sold to 100 people who are already in the auditorium when the doors open at t equals 0 for general admission holders. The doors close and the concert begins at t equals 2. If all of the people, if all of the VIP people stayed for the start of the concert, how many people are in the auditorium when the concert begins? So, what does this represent?
The rate of people entering the auditorium.
So that's the rate of the people entering the auditorium. So if I go up 1, if I take the integral of that, what would that be? The amount of the people in the auditorium, right? So I need to take the integral from 0 to 2 of r of t dt, which would be from 0 to 2, 1380 t squared minus 675 t3 dt. That can go straight in your calculator. What do you get? $980? Okay. Now, that's 980. Those are just general admission folks. Plus the 100 who are still there. So 1,080 people. What's this day? Alright, I would say you've got day 53's homework. I think it's only 1 page. Do day 53's homework, and then you have a free response. How many free responses are there following this? 1 or 3? 4? Work on those free responses, and that's what we'll go over in class tomorrow as we party with Pi Day. So go over those do those free responses too.